All right, let's get into this because this is a wild one. Today, we're unpacking the incredible and, let's be honest, kind of painful story of Wandbot, an AI assistant from the team at Weights and Biases. And this isn't just some feel good success story. It's really a cautionary tale about what can go catastrophically wrong when you're building with large language models. Just imagine this for a second. You've got a pretty good AI system, right? It's scoring around 70% accuracy. You decide, hey, let's refactor the code. Just to make it a bit faster, a little cleaner. When you're done, you run a test and this is what you see. The accuracy hasn't just dropped, it's completely cratered to 23%. A total and utter disaster. And that right there is the central mystery we're diving into today. How on earth does a seemingly simple software upgrade, something developers do all the time, cause a system's intelligence to just, well, evaporate? That's the big question we're going to answer. So this whole story kicks off with a plan. A plan that, on the surface, seemed perfectly reasonable. But it ended up leading the team down a 6-week-long rabbit hole of intense, unexpected debugging. What's so interesting here is the team's initial assumption. They figured, hey, we're just refactoring, we're not touching the core logic, let's just do all the work first and then run a quick check at the end. Well, that quick check turned into a 6-week-long nightmare, all because they were essentially flying blind for those first 2 weeks. And this brings us to the first huge lesson they learned, and it's a big one. Unlike traditional software, LLM systems are just incredibly sensitive. You can't just shuffle the code around and assume the magic is going to stay in the box. Refactoring first and evaluating later is, as they put it, a recipe for disaster. So, when they finally came up for air, the team realized their core problem wasn't even the refactor itself. It was the fact that they were building completely in the dark. They had no feedback loop, no instruments telling them if they were flying straight or just heading into a nosedive. And this led them to a really powerful new philosophy: evaluation-driven development. Think about it like this. You would never, ever want to fly a plane without an altimeter or a compass, right? Well, this is the instrument panel for building LLMs. It makes testing an essential part of the process, not just some chore you do at the very end. Okay, so it's one thing to adopt a new philosophy, but how do you actually build that instrument panel? Let's get into the practical steps the team took to create their safety net, because this is where it gets really interesting. They boiled it all down to this beautiful 3-step framework. First, you create a perfect set of test questions. Second, you see how well a human expert can answer them. And third, you build a robot that can grade the AI's performance for you, automatically. It's simple, but man, is it effective. Now, for that gold standard dataset, they didn't just pull questions out of thin air. No, they went straight to the source, actual queries from their users on Slack and Discord. They used clustering, which is basically a smart way to automatically group similar questions to make sure they had a really diverse mix, covering everything from common problems to weird edge cases. In the end, they had 132 rock-solid test questions. Next up, they needed a benchmark, a target to aim for. So they took those 132 questions and had their own in-house experts answer them, using the exact same documentation the bot had access to. The result? A human baseline of about 67%. This became their North Star, the score they knew they had to beat. Now, obviously, you can't have humans grading every single code change. I mean, that's impossible, right? It's way too slow, way too expensive. So the team did something super clever. They used another powerful AI, GPT-4, to act as an automated judge. This judge was fine-tuned and calibrated against the human scores, which gave them a fast, cheap, and infinitely scalable way to test every single change they made. And with this powerful new evaluation framework locked in, the team was finally ready to make their comeback. Armed with real-time data and a clear baseline, they didn't just fix the problem. They made Wandbot better than it had ever been before. The first massive win was speed. By shifting to a more modern asynchronous architecture, which basically just means the system can do a bunch of things at once instead of having to wait in line, they slashed the bot's response time by a staggering 84%. The user experience got better, instantly. But here is the real kicker. I mean, this is the part of the story that's just amazing. They didn't just get back to their original accuracy. The final system scored over 81%, blowing past the original system and even beating their own human experts by 9%. That is the power of evaluation-driven development right there. So let's quickly break down how they pulled this off, because the overhaul was pretty significant. They moved from a single, clunky, monolithic app to flexible microservices. Think of them like Lego blocks that are way easier to update and fix. They swapped their data library, the vector store, to a faster, more scalable one. And as we mentioned, they made the whole thing asynchronous, so it could work on tasks in parallel. These changes, all guided and validated by their new testing pipeline, made all the difference. So, after all that, what can the rest of us take away from Wandbot's painful, but in the end, pretty triumphant journey? Well, the team distilled their whole 6-week ordeal into a few absolutely crucial lessons for anyone building with this tech. Lesson number 1, and this is the big one: stop treating evaluation like it's the final exam. It needs to be your daily homework. You have to build your tests before you write your code. This one shift in mindset is probably the most important takeaway from their entire story. And here's the really practical follow-up to that. If your tests are slow, developers are going to find every excuse in the book not to run them. Speed is a feature. A fast evaluation pipeline is what lets you iterate constantly, fail fast, and fix things quickly. And they absolutely practiced what they preached. Their first evaluation pipeline took over 2 hours to run. I mean, that's a total bottleneck. They went to work on it, made it asynchronous, and got the time down to under 10 minutes, a 93% reduction. That's what unlocked their ability to improve things at lightning speed. And one final kind of subtle point: LLMs are not like regular software. There's a bit of randomness baked right in. The same question won't always give you the exact same answer, and that means a single test score can be really misleading. The key is to run your evaluations multiple times and average the results. That's how you get a true, stable picture of how your system is performing. Which really just leaves us with one final thought. The story of Wandbot is such a powerful reminder that building with AI requires a totally new way of thinking. So the question to ask yourself and your team is this: is your development and testing process truly ready for the age of AI?